Hello, everybody. This is Fiona Hart from SpyPalm Partners. I'm the facilitator for the TAM webinar series, and welcome to Webinar 7 in our 12-part Transportation Asset Management webinar series sponsored by Federal Highways and Asset. The topic of today's webinar is Asset Management and Adaptation to Change and Extreme Weather Events. The webinars are held every 2 months, and the next webinar addressing data needs, issues, and governance for improved management of highway assets will be held on January 22nd, 2014 at 2 p.m. Eastern Time. The webinar will provide an introduction to transportation asset management data needs, issues, and governance. It will highlight the potential for improving DOT asset management practice and operational performance through a focus on data and for more information, make sure you visit tam.transportation.org and click webinars. You'll find both the previous webinars and the information on upcoming webinars. If you have any suggestions on future webinar topics or have questions for the presenters in this webinar, please submit your comments or questions in the webinars picture, which you see at the top of your live meeting connection. So it's on the menu bar, and there's what's called Q&A. When you click that, you'll get a kind of a entry form on the left of the screen where you can ask questions. So given the number of people who are participating in the webinar, if you have a question for any of the presenters or for all of them, please put them in there, and we're going to take it at the end of the webinar in the sequential order that they come in. So with that, I would like to turn the podium over to Steve Gay and Rob Castellanos from Federal Highways.
Good afternoon or good morning to everyone for joining us today. I'm Steve Gay, Federal Highway Asset Management Team. We are very happy to present this in cooperation with the AASHTO Subcommittee on Asset Management. We believe that holding these webinars are helpful to connect the asset management community around some of these important topics, especially as states are in the process of developing their asset management plans. This is our 7th webinar on asset management, focused on management and adaptation to climate change and extreme weather events. This soon be entering the second half of our 12-part asset management webinar series. This is a topic that has generated increasing interest and attention in recent years. I know we work closely with the Federal Highway Office of Planning and Environment on this. And looking at it from the asset management side and the climate side, you have a lot of interesting issues. I remember not so many years ago, the country said, "Oh, this really doesn't affect us." But as you hear about the wildfires, drought, and the heavy rains, I don't know if there's too many places in this country where it hasn't been potentially a huge impact. And huge impact as we manage our assets. Today we'll hear from a number of knowledgeable speakers from around the country, and I think it'll be a real benefit to everyone. And I think the key, as we look at the MAP 21 requirements for asset management, the key issues to be addressed is risk. A moment ago there was a slide that showed 5 of the documents that our office is dealing with risk. This particular one, Report 5, talks a lot about the issue of climate change, extreme events. As states develop their asset management plans, I think as you go through the presentations today, we're looking at what are the kind of risks, what are the potential impacts. And I think there's some good insight will be brought up. And I know Mike's going to talk about the AASHTO guide and risk and some of the other issues where these very issues come together. me first turn it over to Rob Campananos from our Office of Planning and Environment. Rob?
Thank you, Steve. Our office, the Office of Planning and Environment, we've been working on climate change adaptation for a number of years. Increasingly, in the last few years, we've been working with several of the other offices, especially the Office of Infrastructure, working with the engineers and working with asset managers here to try to integrate climate change across programs. Act 21 requires you to develop asset management plans. To be included is risk at the program and enterprise level. Extreme weather and climate change for that category. If states develop plans, they need to involve environmental staff and the DOTs, state environmental agencies, and others who are focused on making infrastructure more resilient to climate change and extreme weather events. Accounting for future environmental conditions or changes in resulting local impacts is a necessary part of good asset management practice. So what is extreme weather? Weather includes heat waves, intense precipitation events, and hurricanes. What are climate change effects? Climate change effects include higher high temperatures and more frequent heat waves, more intense precipitation, higher sea levels, and stronger coastal storms and higher storm surges. Climate effects can vary by location across the country. Climate change and extreme weather can affect asset management in many ways. Pavement lifetimes can be affected by higher temperatures. Pavement blowouts tied to heat waves have made the news in Wisconsin and Oklahoma and Texas in just the last few years. Extreme precipitation events can wash out roads, culverts, and communication systems. We've seen that recently in Colorado and several years before in Vermont. And this can require unanticipated replacement of facilities or more frequent and gutters. As for coastal storms can also put roads, bridges, and culverts out of service. We've had examples of that in Katrina and Irene, Hurricane Sandy, and most recently, and very sadly, in Hurricane Haiyan or Typhoon Haiyan in the Philippines. Storm surge could be made worse by higher sea levels and or changes in intensity caused by global climate change. The White House has released several important documents on preparing for climate change and extreme weather. The first, the executive order directs, which was just released on November 1st, directs federal agencies to remove barriers that discourage actions to increase resilience. It calls on agencies to reform policies and funding programs that may increase vulnerability. It calls on agencies to support and encourage smarter, more climate-resilient investments by states and communities. The executive order also directs federal agencies to work together to develop and distribute climate preparedness and resilience. Next slide, please. Next slide, please. Thank you. Federal Highways has a number of activities underway, some of which are listed here. Activities underway that are designed to examine vulnerabilities and develop ways to improve the threats posed by climate change and extreme weather events. The first three projects listed here include some common steps because the scale of the studies and the emphasis of each study is quite different. These basic steps include identifying your key or most important transportation infrastructure in whatever study on future changes in climate and estimating what those future changes in climate could be. The third step is assessing the threats, and then the fourth is identifying ways to prepare and promote resilience of that transportation infrastructure given the future threats. The first of these, the Gulf Coast 2 study, applies this process to highway infrastructure and other transportation modes in Mobile, Alabama. We are working with our partners at the South Alabama Regional Planning Commission and the state DOT to assess vulnerabilities and conduct a detailed engineering analysis of 10 facilities. These analyses will include roads, bridges, and culverts, as well as other parts of the infrastructure system there. We'll be looking at these assets to assess resilience and develop adaptation options for them. In addition, we are also developing transferable tools to assist other states in conducting analysis of vulnerability to climate and extreme weather. One of these is a vulnerability assessment scoring tool, basically a large spreadsheet tool that will assist in conducting a quantitative indicator-based vulnerability scoring and a ranking of assets. And the second is a data processing tool to help areas use climate projections for temperature and precipitation. The next study in this list is the Hurricane Sandy follow-up study. Federal Highways is also sponsoring, the second is the climate resilience pilot. Federal Highways is also sponsoring a second and larger round of climate resilience pilot projects in cooperation with 19 agencies, including 14 state DOTs. Two of the speakers today, Garth and Elizabeth, lead California and New York. The projects range from engineering studies of specific highway facilities to broader studies of vulnerabilities and risks, which can inform asset management systems. The projects are using a federal highway analytical framework to assess vulnerabilities and develop options to better prepare for future risks. And the lessons learned from these 19 pilot projects will be used to update that framework, which we call the Climate Resilience Framework, in 2015. The third study is the Hurricane Sandy project, and the objective of that project is to assess the damage caused by Sandy, as well as other storms, on the transportation assets within the greater New York, New Jersey, and Connecticut metropolitan region. Also to assess the vulnerability of those assets to the impacts of extreme weather events and the possible future impacts of climate change, and to identify adaptation strategies to increase the resilience of the transportation system. Federal Highways is also working to update HEC 25, which is the highways in the coastal environment, and to add a second volume to it, guidance to support design of coastal transportation in the context of extreme weather events and climate change. Federal Highway issued a report several years ago summarizing the state of knowledge on projected regional changes in climate for transportation officials, which we call the Regional Climate Change Effects Report. More recent information is also available in the draft National Climate Assessment Report, which is currently online. It summarizes past changes and future trends in climate change, examines climate change as it relates to multiple regions and sectors, including transportation and other sectors like energy. This document can be useful to groups who to work with when putting. It is useful to work with different kinds of groups when, to rephrase that, state DOTs, when they get to the point of wanting to pull together climate information, in addition to looking at various reports that are online, including this one, it's also useful to work with people that you may know in your area. A good first step is to reach out to university climate researchers in your area to get information from them on the kinds of climate projections they're using. You can also work with NOAA, and NOAA has regional integrated science and assessment offices around the country, also known as regional support. Then if we could go to the next slide, please. So this next slide is just a graphical representation showing where all the projects are that we have across the country. You can see we have projects on both coasts, but we also have projects in some of the inland areas in Iowa and Minnesota and Michigan and Tennessee. And again, this slide summarizes projects including the current ongoing 19 pilot projects, as well as Gulf Coast 2 and the Hurricane Sandy project in the New York area. And lastly, I just mentioned that Federal Highways issued a memo about a year ago that clarifies eligibility of adaptation work, including both developing risk assessments and vulnerability assessments, and also updating projects to prepare them for future changes in climate. So those kinds of projects were already eligible for federal aid and federal lands funding. The purpose of the memo was to just clarify the fact that these kinds of projects and these kinds of efforts can be funded with Federal Highways funding. So that's all I have. I'll turn it back over to Hannah.
Thanks, Rob. So today we'll hear 4 perspectives on asset management and adaptation to climate change and extreme weather events from folks working at the forefront of these areas. Presentations will highlight both successful approaches and some important lessons learned. Addressing climate change and extreme weather adaptation in the context of transportation asset management is emerging as an area of concern and focus for many agencies and all of you who are participating in this webinar. Today we'll explore the specific benefits that state DOTs are achieving by proactively taking on these challenges. We will also address some of the key success factors that may be applicable for many of you in joining us today who are just beginning to engage with these issues. Next. As I mentioned previously, the purpose of the webinar series is to share lessons learned, ideas, knowledge with the asset management community. For this webinar, the primary learning objectives are building working knowledge of key concepts and definitions relevant to asset management and adaptation to climate change and extreme weather events, understanding specific approaches that agencies are taking to address these issues today, and beginning to apply this knowledge in order to answer the following questions. What is important to consider in proactively addressing the risks due to climate change and extreme weather events in the context of transportation asset management? What progress has been made in recent years in this area, and how is this topic important in the context of MAP 21? For today's agenda, we started off by hearing from Steve Gay and Rob Kapelanis. I will introduce our speakers before each presentation, but in brief, we will have Mike Savonis of ICF International, who will set the context for this topic. Next, we will hear from Chad Allen of the Vermont Agency of Transportation, and he'll talk about building asset resiliency in Post-Irene, Vermont. Our third presentation will be from Caltrans with a presentation by Garth Hopkins on the response to climate change impacts affecting the state highway system. And our fourth presentation, we will hear from Elizabeth Lennon of New York State DOT, who will address planning for extreme weather in New York. As we mentioned earlier, we will have Q&A at the end, and just please submit your comments and questions using the webinar Q&A feature. So with that, our first presentation is from Mike Savonis of ICF International. Mike has 25 years of experience in transportation policy with extensive expertise in climate change, air quality, and emerging environmental issues. He was instrumental in the creation of the U.S. DOT Center for Climate Change and was co-chair of the Transportation Research Board Climate Change Subcommittee. He has authored several papers on climate and air quality and directed the Gulf Coast studies for the U.S. Climate Change Science Program. Now I'll turn it over to Mike.
Thanks very much, Hannah. And hello, everybody. I hope you're having a good day so far. I think you have to really celebrate good ideas, and asset management is one of those good ideas. It's nice when requirements actually coincide with good ideas. I believe that it's the best of strategic planning. At its heart is making the best use of your resources to fulfill your mission. There's a reciprocal relationship between asset management and vulnerability assessment. If you have a good asset management system, you can effectively understand your vulnerabilities much better than otherwise. At the same time, if you're doing your vulnerability assessments from extreme weather or from climate change, that will inform your asset management system. And we really do need to look at these as an integrated system. Extreme weather events and climate change are an important element of an asset management system, but they're really only one risk, and you have to look at this in a multi-hazard kind of way. Can I have the next slide, please? So you're going to hear a lot about extreme weather risk over the course of this webinar. The other presenters, I'm sure, will bring it to heart. I will keep my comments fairly brief on this matter, mostly from lessons learned from recent work where we've supported AASHTO. Next slide, please. It's not an overstatement to say that extreme weather has disrupted transportation systems in every region of the United States. We have seen sinkholes swallowing cars in Minnesota after heavy rains. We've seen airplanes sinking into the tarmac on the runway at Reagan National Airport. And climate change is likely going to make this worse, not better. The good news is, due to the really good work at Federal Highway, at AASHTO, and among the states, transportation agencies have increasing experience in dealing with extreme weather events and managing weather vulnerability. Next slide, please. So what's happening with extreme weather? Well, the first thing we know is we don't have to look to climate change to recognize that extreme weather events are changing. On average, the U.S. has experienced more frequent heat waves and record-breaking hot summers. It's already happening in the past. Heavy rainfall events have increased, particularly in the East and Midwest. And if you take a look at the graphic there, you see in the Northwest, the incidence of heavy downpours, extreme rainfall events, have increased by 74% from the 1950s. Climate change is going to make both of those effects worse. Coastal areas are experiencing frequent and severe flooding, and sea level rise will make this worse because as the seas rise and storms come in over it, you're going to see more coastal flooding. The costs of this are really twofold. Certainly there are costs to each agency that has to deal with these extreme weather events, cleanup costs. But just as significant, and perhaps even more significant, are the costs to society. If you look at the box in the lower right-hand corner, Michigan DOT, which has really done some great work in this area, has estimated that the economic costs of disruption from a snowstorm range from $66 to $700 million a day just for one day shutdown due to impassable roads. Next slide, please. So just to get us all on the same page, I'd like to talk a little bit about points into transportation asset management. These next few slides are coming from a white paper that AASHTO asked us to do. It was authored by Mike Meyer, Emily Rowan, Ann Choate, and myself, and I'm just going to cover it in brief to kind of give you the key points as to where asset management really can inform vulnerability assessment. Next slide, please. So I'd like to start with the box on the right, and it's from the AASHTO Implementation Guide. Transportation asset management is a strategic approach to managing infrastructure focusing on business processes for resource allocation and utilization with the objective of making better decision-making based on quality information and well-defined objectives. Everything is in that phrase. It's really a very well-constructed phrase. Business processes, budgets, planning, for resource allocation, better decision-making based on quality information and well-defined objectives. At the heart of asset management are the core questions that you see on the left. What's the current condition of my assets? What are required levels of service? Which assets are critical to my service delivery? How do I fund them? What are the best investment strategies? Looking across capital investments and operational and maintenance investments as well. Next slide, please. It starts at the top. Now, then just 4 of the 14 steps, but I think the 4 are perhaps the most illustrative of what asset management's all about. It starts at the top with goals and objectives. What is your agency trying to do? How are you going to do it? But just as important as that is the base of the pyramid. It's got to be based on good data collection and performance metrics. It's an upward rising pyramid where everything reinforces all other aspects of the asset management system. Next slide, please. Next slide, please. The second key entry point that I would like to raise is about service planning. What levels of service do I provide? 2 important elements here are agency-wide strategic performance measurement. During extreme weather events, agencies need to keep tabs on its performance. Well, you know that everybody else will be keeping tabs on your performance as well. So it certainly behooves you to keep tabs on your own performance during those events. Managing weather risk is a part of that, and it has a reciprocal relationship. As an integrated system, if you manage your weather risk well, you will have benefits to all other aspects of your mission, including safety, mobility, accessibility, and reliability. The second key element to service planning is managing your risks, making sure that you can maintain service in the face of certain risks, using your investment strategies to manage those risks and minimize them. Shown below the risk management bullet is one of the ways that is done for climate change and extreme weather events. Risk is the product of the likelihood of occurrence and the consequence if the worst happens. And you can see that you can rate these things, the likelihood from a very rare occurrence all the way up to a frequent occurrence, and the consequences from insignificant all the way to catastrophic. Typically, you'd want to focus on the lower right-hand corner of this kind of a chart, which is where your priorities begin to jump out, things that are high consequence and high likelihood. In the case of extreme weather events, sometimes your likelihood may be quite low, but your consequences are so high that it's worth investment to try and minimize those risks. Next slide, please. The third key element is life cycle management, looking at the costs over the life cycle of the asset, looking at routine maintenance, rehabilitation, and renewal at regular intervals, looking at operations and maintenance costs as well. Weather events can impact asset performance. Heat and freeze-thaw cycles both have impacts on equipment and materials, and temporary or sustained flooding can have an impact on your assets. Next slide, please. And then finally, this was originally in the AASHTO implementation guide under data and information needs, but I kind of like it as a wrap-up because it really captures all of the elements of asset management. Again, starting from the bottom, it starts with data. Good data will yield better decision-making. But you also need analytical tools moving up, and the more you have better analysis, the more you are certain about your impacts, and the better your service will be. Planning, programming, and management is part of those business processes, and even above that, setting your goals for budgets and investment processes. How can you improve the system as a whole is really the underpinnings of asset management. Next slide, please. So I want to talk a little bit about how asset management systems can support vulnerability assessment. Next slide, please. So this is our conceptual framework that we've developed at ICF. On the left, you see the vulnerability assessment. What is exposed? What assets are exposed to extreme weather events and to climate change? What is their sensitivity to those effects? And what is your adaptive capacity? This is really the mirror image of the data collection and analysis side of asset management, looking at the risks. Developing asset vulnerability scores is a way of looking at your performance management or your anticipated performance management. It's a way of kind of linking where you should put your investments for better performance and recognizing where your risks are. And then you get to adaptation. How can you improve the system in the face of these extreme weather events with targeted investments? And that's really all about service planning and budgeting. Next slide, please. I'd like to just quickly walk you through two examples that we have done that really kind of illustrate how you might use some of these things and how asset management can really help you with vulnerability analysis. The first is the Federal Lands Management tool that we developed for them. they took a look at the refuges in the southeast, and we helped them examine inland flooding, coastal flooding, wildfires, and we're able to look at an aggregate measure of the risks for all hazards. And we could do that for each of the refuges that are listed there on the left and come up with scores. Now, this is done typically by a scoring process, and that's something that Rob Kefalinos made reference to. You can use expert judgment. You can use expert judgment informed by some data analysis and objective information, and develop some of these scoring mechanisms. Shown on the right is the output. Looking at the number of highly vulnerable assets along the x-axis as compared to the value of those assets. And that gives you a sense as to where to put your investments. The Merritt Island Refuge up there in the upper right-hand corner of the graph kind of jumps right at you as something that's both very valuable and highly vulnerable. Next slide, please. I'm taking a more micro look at this. We did some work that is forthcoming, coming out of SEPTA, the transit agency in Philadelphia. And it can give you a sense as to how agency information can help you take a hard look at your payroll costs per event and how climate change might affect that. So we took a look at the historical weather impacts, and luckily SEPTA had this information. We were able to correlate it with the intensity of the weather event, looking at high heat, heavy rainfall, snowfall, and tropical storms. And then you begin to get a sense as to what the payroll costs actually were. Now, these are payroll costs just to the agency and just in terms of the operating budget, I believe. Taking a further look at this, we can then start using climate modeling to determine how much more frequently some of these events are going to be. And again, some of the information is very clear and you can act on it. And in some cases, it's not as clear as you would like. And of course, that may be less actionable. But in those places where you're expecting high heat, for example, and that it could be an increase of 200% or 300% in high heat events, you begin to get a sense that maybe I want to start focusing on some of those investments. Next slide, please. So I'm going to finish up here with just what I think are some good practices as we have worked with Federal Highway and worked with AASHTO in climate risk analysis in particular. One, the obvious. Asset management is useful, and you should use asset management in decision-making on extreme weather events as part of a multi-hazard analysis. That you can identify reasonable goals and levels of service, perhaps during extreme events, and certainly after. How quickly can you get back up and running? How important is asset protection, which of course is always one of the major goals. It's important to understand weather impacts and their direct and indirect costs. And there's several pieces to this. One is monitoring weather events and collecting the information on extreme weather. Two, collecting the information on the costs to the agencies. And then three, to the best of your ability, collecting the cost to society. As many public agencies are very aware, we serve society. Fourth, develop approaches to track and obtain data on extreme weather events, and develop performance indicators is the key element here, that trying to target your levels of service and monitoring how well you're doing is a key action. And then finally, all the information in the world will be useless unless you develop triggers for action. At what point do you make those investments? Can I have the next slide, please? So thank you very much for your attention. I do believe in my deepest heart of hearts that this is a very good initiative, that the more we can use asset management and for extreme weather events and climate change, the more we will make better decisions. And I look forward to your questions at the end of the webinar. Thank you. Renee, back to you.
Okay, thank you, Mike. I love that you make the connection to the Transportation Asset Management Guide, which really is a resource that we should all be using to be consistent and have the material you need to implement asset management. Before we move on to the next speaker, I just want to respond to a couple of questions that are pertinent at the moment. One is the presentation will be available along with a recording of the webinar at the Asset Management Subcommittee website on transportation.org, which is the AASHTO website, and also on the Federal Highway Office of Asset Management site. There will be a pointer to the site. So you'll get both the presentation and the recording. For all the speakers, there was a comment about speaking louder. I think in general it's been loud enough, but if all the speakers could just stay close to their microphone when they're speaking, I think that would make it easier for the audience. And then one person wanted the slides to be bigger. I think that is a control that's locally on your computer, not from ours is as big as it can get. And so please just check on how you can change it from your local site. All right. Our next presentation is from the Vermont Agency of Transportation. Chad Allen is the Asset Management Manager for VTrans. In this role, Chad works to facilitate, coordinate, and develop a comprehensive asset management system, including the development of a transportation asset management plan in accordance with the federal MAP 21 requirements. Previously, he served as both a geotechnical and quality engineer, utilizing risk, performance, and strategic management principles. Chad is going to speak to us about building asset resiliency in Post-Irene, Vermont. Chad.
Thank you, Hiana. Good afternoon and good morning. I'd like to thank Hiana, AASHTO, and Federal Highway for the opportunity to present to you today. Vermont was asked to participate in this webinar due to our experiences responding and recovering from Tropical Storm Irene. And we believe that the frequencies of these climatic events are increasing. When I was asked to give a presentation on building asset resiliency in Post-Irene, Vermont, I asked myself, what does resiliency actually mean? By definition, Webster's dictionary does not define the term resiliency, but refers the reader to the noun resilience. Resilience is the ability to become strong, healthy, or successful again after something bad happens. It is further defined as the ability of something to return to its original shape after it has been pulled, stretched, pressed, or bent. Further review of Webster's definition reveals similar thoughts. It describes resilience as an ability to recover from or adjust easily to misfortune or change. Tropical Storm Irene definitely stretched and pulled us, and as a result, we have increased our awareness, abilities, and preparedness so that the next time disaster hits, we will be able to reduce our losses and increase our responsiveness, allowing us to return much sooner and efficiently to our original shape. Today's presentation is focusing on Vermont's lessons learned and our ability to recover from the devastating impact of the floodwaters resulting from Tropical Storm Irene in 2011. Prior to getting into the specifics of Irene, I want to present some slides to help pull in the climatic change piece of this webinar series to help set the table for Irene. I'm no expert on climatic change, but from what I've learned, changes in our climatic system can occur externally or internally through any one of these factors. For example, an external change may involve a variation in the sun's output, which would externally vary the amount of solar radiation received by the Earth's atmosphere and surface. Internal variations in the Earth's climatic system may also be caused by changes in the concentrations of atmospheric gases, volcanic activity, and changes in surface or atmospheric reflectivity. Because there are so many factors and variations of factors, our climate remains in constant flux. Scientists believe that normal cyclical variations in 3 of the Earth's orbital characteristics is probably responsible for most of our historic climate changes. However, not all climatic change factors can be related to the Earth's orbit. Us humans also have an impact. This is often referred to as our carbon footprint, which has historically been defined as the total sets of greenhouse gas emissions caused by an organization, event, product, or person. In recent years, a larger percentage of precipitation has come in the form of intense single-day events. 8 of the top 10 years for extreme one-day precipitation events have occurred since 1990. The prevalence of extreme single-day precipitation events remained fairly steady between 1910 and 1980, but has risen substantially since then. Larger single-day rainfall events means limited time to allow for precipitation to infiltrate our soil, leading to increased runoff potential. Now, we've seen this slide a little bit in the past. The EPA refers to heavy precipitation as instances during which the amount of precipitation experienced in a location substantially exceeds what is normal. Although what constitutes a period of heavy precipitation can vary accordingly to location and season, climate change can affect the intensity and frequency of precipitation. Warmer oceans increase the amount of water that evaporates into the air. When moisture-laden air moves over land or converges into a storm system, it can produce more intense precipitation. For example, heavier rain and snowstorms. In Vermont, we call these storms nor'easters. In recent history, Vermont has experienced that these heavy precipitation events increases the likelihood of a damaging flood event. This map shows the aerial extent of flooding in Vermont since 1973. The Irene flooding is the black dotted line that cuts diagonally across Vermont's midline, encompassing central and southern Vermont. This graphic here depicts many hazards and risks that threaten to impact the management of our assets within our transportation infrastructure. From devastating flooding to record-breaking snows, 2011 was a year particularly active in tragic weather across Vermont. Significant spring rainfalls coupled with large snowmelts left ground conditions in a saturated state, thereby increasing the runoff potential from future rain events. In 2011, the state experienced its largest 24-hour snow accumulation for any day in March, with records extending all the way back to 1888. The snowfall over a 24-hour period totaled over 17 inches, with a total storm accumulation of 25.8 inches, third all-time highest. This particular event caused power outages across the state, as well as localized ice jams and flooding. Spring snowmelt coupled with spring rainfalls resulted in historic flooding along the shores of Lake Champlain. Usually the lake levels vary seasonally from 95 to 100 feet above sea level. However, during the spring of 2011, Lake Champlain rose to an elevation in excess of 103 feet, more than 3 feet above its normal flood stage and 1.5 feet over its major flood stage. Irene wasn't the first disaster event for Vermont in 2011. Contributing to the high lake levels was a Memorial Day weekend storm dumping 5 inches of rain on areas of central and northeastern Vermont. This is a radar image of Irene bearing down the northeast on August 27, 2011. Rainfall events during August 27th and 28th, 2011 ranged from 3 to more than 7 inches of rain over the entire state. Tropical Storm Irene produced catastrophic river and flash flooding across Vermont on Sunday, August 28th. This was a scale of devastation not seen across the region since the epic floods of November 1927. Nearly a dozen Vermont communities were isolated for days due to the loss of numerous roads and bridges. Nearly 2,000 road segments were damaged, 118 sections of state roads and 175 local roads completely washed out. Among nearly 300 damaged bridges, several iconic covered bridges were heavily damaged or completely destroyed. Over 800 homes and businesses and several rail and major telecommunication lines were damaged or destroyed by fast-moving floodwaters. Here are some pictures showing some of the devastation from Irene to our assets. Multiple sections of Vermont 107 were wiped out. Portions of villages and homeowners were cut off from emergency services for multiple days. Although we did lose several bridges, my experience was that this washout was typical. The rivers needed room to move laterally and thus went around or through many bridge approach embankments. Note the bridge plaque on the portal frame indicated construction 1899. Restoring freight and removing speed and weight restrictions from our rail bridges was one of our priorities in the management of our assets following Irene. Using a color coding system where red roads are closed and green roads are open, the map on the left shows the status of our infrastructure after Irene on August 31st, 2011, while the map on the right shows an updated status on December 31st, 2011. Some of our lessons learned, we've been loosely grouped into 5 categories: emergency response, communications, innovations in technology, employee development, and risk management. There are several lessons that cut across multiple categories. Regarding emergency response, we use an ICS structure, and we realize that it promotes resiliency and it allows for rapid expansion and contraction of personnel and services to facilitate tactical deployment and utilization of resources. Recognizing the importance of the ICS structure as a way to increase our preparedness, we provided ICS training to most of our staff directly related to emergency response and recovery tasks. The strategic establishment and communication of goals during emergencies is critical to managing the public's expectations and those of the response and recovery personnel. It is also important to communicate early and often, and then circle back and recommunicate goals, recognizing that those affected are in various stages of recovery. In enhancing our preparedness for future events, VTrans has recognized the importance of partnering on the state and regional levels, as well as fostering its public-private nonprofit relationships. New technologies are being developed and brought online in response to our need to be better prepared, to be more resilient. One such system is Vermont Alerts, which is a free service to the public, allowing the user to stay informed of threats such as pending disasters, weather conditions, and public health notifications. During Irene, we realized the benefits of providing up-to-date and accurate travel information. VTrans strived to be specific regarding which roads were open and for which type of vehicles. For instance, some roads were only open for emergency service vehicles, while all other vehicles were denied access. This provided rubberneckers and vacationers with an opportunity to plan their trip around impacted areas. Social media and maps with mobile interfaces greatly enhanced our communication abilities. Regarding innovation and technology, cross-functional teams were developed which included members from VTrans operations and program development divisions, as well as personnel from the Agency of Natural Resources. The need for real-time and accurate reporting led the agency to wider use of handheld mobile devices and the implementation of other technologies. In January of 2012, VTrans implemented its Accelerated Bridge program, adopting innovative technologies and bold strategies field-tested in our Irene response. ABP shortened the time it takes to design, permit, and build a number of structures. For example, the target duration to develop plans for an ABP project is less than 24 months, as opposed to 60 months for a conventional project. Irene has sparked VTrans' interest in corridor management opportunities, and we're applying the concepts of corridor management in the execution of our final recovery projects from Irene. VTrans is requesting, reviewing, and implementing the recommendations and input of fluvial geomorphologists with regards to its hydraulic studies and ultimately the sizing of our bridges and culverts. Greater use of GPS and GIS during Irene has increased its use and applicability post-Irene. Here where you see the VTrans rail section has recently adopted an ArcGIS map for asset management and emergency response. We touched on the ICS training in a previous slide. However, another training that we provided to our personnel centers around roads and rivers management. Currently, there are 2 training tiers for roads and rivers management training. Tier 1 is an online course. You see the hyperlink here in this slide, and is available to everyone. It is designed to create an overall awareness and understanding of river processes, what is meant exactly by river equilibrium, what causes rivers to be stable or unstable, what role does transportation infrastructure play in river stability, and why is it in our best interest to work towards river stability. Tier 2 training is a 3-day training that consists of a mixture of short presentations, hands-on river modeling exercises and demonstrations, and in-field investigation of interactions between river processes and transportation infrastructure. These trainings have been instrumental in developing the cross-functional relationships that we touched upon earlier. We are working with river scientists to implement new typical sections to repair highway embankments adjacent to our rivers. We're also working backwards, considering first the needs of the waterway and meshing that with the infrastructure demands instead of the other way around. Fluvial geomorphologists are assisting us in defining stable channel dimensions from which side slopes can be engineered and constructed to match into the roadway. We are using our rivers and roads training to train personnel ranging from heavy equipment operators to design engineers on how to best work in rivers and plan and design long-term for asset resilience. We are also researching methods to better quantify infrastructure risk and vulnerability so that we can strategically invest in improvements and minimize infrastructure harm and transportation disruptions from future events. Here we see in this slide the effects of hydraulic and geomorphological improvements before and after. VTrans' approach to resiliency, which we have presented as our ability to minimize losses from a disaster and to bounce back or recover quickly, centers on our ability to identify, prioritize, and mitigate known threats or risks. One such approach is to examine our infrastructure vulnerability adjacent to our rivers. The following few slides uses a section of Vermont 100 between Killington and Pittsfield to provide a general overview of this process. For those folks unfamiliar with the LiDAR terminology, LiDAR is a technology similar to radar that uses lasers to determine the distance between objects. The mapping of our flood vulnerability begins with a process-based approach to identify and prioritize risk in river roadway corridors. We use hydrologic and hydraulic modeling to quantify river and floodplain erosion potential while using the LiDAR information to develop contours and cross-sections along our highways. Our ultimate goal is to identify areas of our roadway where there's limited relief from the river and or that are susceptible to erosion during flood events. Here are 3 cross-sections developed from the Vermont 100 LiDAR data. In 2012, VTRAN conducted a spring scanning tour that analyzed the high-quality LiDAR data that was collected post-Irene. The LiDAR data was used to develop a prediction model that identifies at-risk areas along our state highway system adjacent to rivers and streams. The following parameters were used to develop and execute this model: horizontal and vertical distances between roadways and watercourses, roadway slope angle of repose, topography of river valleys, a 100-year storm event. When run, this model predicts roadway slopes that are at risk for scour or erosion. We have found that this model can be a useful tool that enables VTRANS to make durable modifications to our roadway slopes to protect our infrastructure and increase its resilience by minimizing future losses. To achieve resiliency, we must understand what assets are strategic and the risks and interdependencies affecting their performance. We must be mindful and anticipate risk while continuously improving and diligently seeking the elimination of potential hazards and failures. We must strive to develop proactive and innovative solutions to reduce future asset losses. A couple key takeaways from my presentation today. VTRANS has experienced several recent disaster events due to flooding. From these events, we have increased our ability to respond and recover quickly, efficiently, and effectively, thereby increasing our resilience. We have committed to training our personnel in the principles of river science and management, thus effectively changing how we manage our assets and protect our environment. One of our programmatic goals of our asset management program is to manage our assets in such a manner that we become a high reliability organization, an organization that is able to avoid losses despite operating in an environment where there can be high potential for error and losses. And when unexpected events do happen and losses are incurred, we will remain resilient in containing our losses while quickly and efficiently recovering from each event. Through our asset management program, we strive to increase our resiliency through the utilization of continuous improvement and a mindfulness or awareness of our assets' performance, seizing opportunities that may otherwise never be realized. Thank you for your time and attention. I'll answer any questions that you might have at the end of the presentation.
Thank you, Chad, for that fantastic content-rich presentation. Our next presentation is from Caltrans. Garth Hopkins is going to speak to us about the upcoming efforts that Caltrans will be undertaking to address vulnerability of the state highway system to climate change impacts. Garth is currently the Chief of the Office of Regional and Interagency Planning at Caltrans. He and his staff are responsible for a wide range of planning activities, including developing policies for long-range transportation plans, incorporating environmental mitigation activities into those plans, climate change activities, addressing federal air quality regulations, regional blueprint planning, and addressing transportation land use planning efforts. Garth has been at Caltrans for over 25 years and has prior work experience in transportation system planning, bicycle and pedestrian planning issues, and aeronautics. Now let's give our attention to Garth.
Hi, thanks a lot, and hello everyone. Okay, so first of all, kind of an overview of California and the transportation system, the state highway system that we do have here in our state. Caltrans is the owner and operator of a large and really complex highway system. In terms of our assets, we have over 50,000 lane miles of roadway, 2,000 bridges, 250,000 acres of roadside, and 25,000 of those are landscape acres, and 88 rest stops and 340 park and ride lots, just to kind of name off a bit. So the bottom line is we have a considerable amount of assets here that are under the responsibility of Caltrans, and a lot at stake here, I think. And we're moving, there's 32 million registered vehicles here in our state. So, we've got a large population to deal with. So, at any rate, next slide, please. From a climate change perspective, again, California, we've got a lot of varied climatic regions, and we're going to be experiencing, along with a number of other states, a wide range gamut of the climate change impacts, from sea level rise, the heat, increasing precipitation, which cause flooding, landslides, and erosion. And so we're really going to, based on the information that we've obtained, we will be really experiencing a number of significant related climate change impacts. Next slide, please. And what are we doing from a planning standpoint to address these potential future impacts to the transportation system? Well, first of all, we were fortunate enough in California to receive several FHWA grants for the climate change vulnerability pilot projects. The first one they'll talk about real briefly here is in our District 1 office, which is located, you can see on that map, in the extreme northern part of the state along the coast. And by the way, Caltrans, we have the state divided into 12 regional district offices, and that's that map on the right there. It does show that each of our locations of our 12 district offices around our state. And so this first one, the FHWA pilot project, was for our District 1 office we recently received. And what we're going to be doing in that, as part of that vulnerability assessment, we'll be looking at the entire 4 counties located within our District 1, located there on the north coast of the state. And then we'll be focusing in detail. There's 4 locations along state routes that we're aware of that are going to be impacted by climate change, and we'll start looking at specific design alternatives for those 4 routes, 4 segments of the 4 routes that will or may be impacted by sea level rise. And other adaptation options will be analyzed as well. The second FHWA pilot is occurring down in the San Francisco Bay Area, and that's in our District 4 office there in Orange. But this is really the funds were received by the San Francisco Bay Area MPO, Metropolitan Transportation Commission. And this is the second FHWA pilot grant that they were able to receive for climate change. And it's going to be it's a collaborative effort in the San Francisco Bay Area of regional, state, and federal agencies to increase the preparedness and resilience of the Bay Area communities to sea level rise and storm event flooding. And the project began back in 2010 during the first round of the FHWA grants, and it continues with the second round. And given the large amount of communities that are and population that are located along the perimeter of the San Francisco Bay, that region has a particular key stake in terms of impacts of sea level rise upon the community. And so they've been very progressive in dealing with the issue and studying it and figuring out ways to come up with alternatives to the sea level rise impacts. Next slide, please. Moving on to asset management, and what is Caltrans doing regarding asset management? Our director's office recently formed a committee on asset management in February of this year, and the committee is responsible for making decisions regarding the developing a vision for Caltrans asset management, for the Caltrans asset management plan. And the Caltrans asset management plan will include bridge, pavement, culverts, ITS elements, such as ramp meters, loop detectors, etc., on the state highway system. Next slide, please. And as part of our asset management effort, Caltrans, within Caltrans here, we have developed a total of 6 teams for the development of our asset management plan. These 6 teams are on information, data management and integration, organizational change management, risk analysis, asset analysis, financial analysis, and local engagement. So consequently, Caltrans, we're really gearing up to do a significant amount of work, in terms of asset management, and we've got a good team in place to handle that. Next slide, please. Moving into a specific, another specific effort that we will be shortly undertaking is helping to identify where the state highway system is vulnerable to climate change impacts. And starting next year, we'll start to take a look at conducting a Caltrans district-by-district assessment. Being that California is a pretty large state, which is from a feasibility standpoint, and we're unable to do the whole state at one time. So we're going to kind of break it down by Caltrans district and do a district-by-district assessment of the state highway system and its potential vulnerability to climate change impacts such as sea level rise, flooding, and landslides, etc. Also, a key part of our effort will be to coordinate closely with our asset management team during while we're conducting these district-by-district vulnerability assessments. Next slide, please. As part of our vulnerability assessment, we will identify the key assets along each route within the particular Caltrans district. And this effort will include a number of units within Caltrans, most notably our maintenance staff. This is going to be this vulnerability assessment will be imperative to include a wide range of our planning or our staff within our department, not just planning or maintenance, but go across a wide range and include a number of our staff that has knowledge on where our key assets may be vulnerable to climate change. And of course, we'll also be including our regional transportation partners as well as we conduct this particular effort. And like I say, given the funding limitations, we won't be able to have a complete statewide assessment probably for 4 years or so, because it's going to take us a while to go through all 12 districts. And so, we're really looking forward to that effort, and hopefully it'll move our state a lot closer and forward to be able to identify where our key assets may be vulnerable to climate change and start planning and designing accordingly. So that's all I have. Thank you very much.
Thank you, Gart. I hope that someone from Caltrans will come back and speak about some of the outcomes of all of the work you're doing in asset management and climate change.
Sure, we'd be happy to.
Good, good. Our final presentation is from New York State DOT. Elizabeth Lennon has been with the New York State Department of Transportation since 1994. Her career has focused on environmental issues throughout. Ms. Lennon is currently addressing sustainability, energy, and climate change issues from the planning and policy perspective within the statewide policy bureau. Previous experience at NISTOT includes construction, design, and maintenance in Region 8, and before transitioning to the Division of Planning, she served as the Special Assistant for Environment to the Director of Operations. Now I'll turn it over to Elizabeth.
Thank you, and good afternoon to all of you on the phones. Thanks for sticking it out all the way through the end. I am Elizabeth Lennon with New York State DOT, and today I'm going to talk about the climate risk in New York and how climate change and extreme weather risk can be integrated into NISTOT's asset management and the Transportation Asset Management Work Plan. For this integration to be successful, climate change and extreme weather risk must be quantified somehow. I will also talk about flooding considerations and NISTOT's involvement in vulnerability assessments. Next slide, please. A couple of words about NISTOT's long history of engaging in climate change activities. In 2008, NISTOT launched an extensive climate change effort with a team comprised of over 70 staff members. The adaptation work group of about 10 members is still active today. Some early efforts included the New York State Sea Level Rise Task Force, which released a report at the end of 2010. This report is available online. Another effort was NYSERDA's extensive climate research, which defines 7 distinct climate regions for New York State. You can see this on the map right here. And looked at the state's climate change projections and impacts. This is our main climate change guidance for the state of New York at this time. NYSERD participated in the development of the draft New York State Climate Action Plan, and this is a partner in many other efforts, including the Climate Smart Communities effort, which is a local initiative. Well, it's not a local initiative, I must correct myself. It's for communities, but it's basically managed from the state level. We're also proud that we further research as much as we can here in New York State, and something to look out for is the launch of New York State's Climate Change Clearinghouse in 2014, next year, which will be home to many of our state's research efforts and will allow for an information exchange. Next slide, please. As mentioned previously, New York State has invested resources in defining its climate risk. Through NYSERDA's climate research, New York State considered all the climate hazards. The strongest risk to New York State's transportation infrastructure is related to water. Flooding from intense precipitation or from storm tides is of major concern here in New York. I have the 2 words tropical cyclones and non-tropical cyclones up there. That's a reason you would think that those tropical cyclones are the most destructive and the most costly. Just think of Sandy and Irene. Yes, they are, but there also is a lot of damage being wrought by summer thunderstorms with heavy downpours and straight-line winds. Sea level rise is of concern as we progress further into the 21st century, especially 2050 and beyond. And of course, we also do consider heat, extremes, wind, and all the other climate factors. Next slide, please. We have a map of New York. As you can see, we have an extensive water system, 10 major rivers, lots of lakes, 70,000 miles of streams. Come and visit. All these streams can cause concern when they're overflowing the banks. The coast is a beautiful place to be and live, Long Island, New York City, and the tidal Hudson River. But one has to consider the effects of sea level rise and storm surge in these areas. When looking at this map, I'd like to mention where some of the greatest impacts of the recent storms occurred. Could you hit the enter button there? It's one of them, Irene, late summer of 2011, and there's Lee right on the heels of Irene. This is where the greatest impact areas were. And as you heard from Chad earlier, of course, Vermont was greatly impacted as well. So I could have extended that bubble right into Vermont. Sandy came in October 2012. Huge impact in the downstate area. This was a $65 billion storm, and I think only second to Katrina. Much of the region along the coast is still in recovery more than 1 year after Sandy struck. Next slide, please. We've seen this slide before. 2 other folks had this up there, but mine has the umbrella lady. You didn't have, the others didn't have that. Basically, the point of this slide is we're getting more rain in the form of heavy precipitation, and we may experience more drought in between. That's for the northeast here. Next slide, please. Let's look at this risk of flooding a little bit more closely. New York State has great in-house resources. One of those resources is our hydraulic engineer, George Long, who looks at studies and has also performed his own analysis. In many watersheds of the state, that 1% risk storm often translates to a 10% storm by the mid-century. George has developed summaries of climate effects for many of our regions, and you can see the top of one of these right here on the slide. Other examples of New York State-related research is our effort with NYSERDA and the folks at Cornell to determine what the increase in intense precipitation projections are. Preliminary findings show that precipitation intensity of the 100-year storm will increase by 10 to 20% in New York State by mid-century. That research study will also look at updating IDF curves. NISTAD is also supporting the expanded use of the USGS StreamStats tool, which will allow input for projected precipitation to model stream flow data. This will be very useful to engineers. We're also eagerly awaiting the updated NOAA Atlas 14 for New York State. Next slide, please. I have to look at time really quickly. How are we doing? Okay.
So just speed it up a little bit.
Oh,
Okay.
it doesn't mean I will talk faster, because then nobody might understand me. Steve Jobs once said, "It is easy to connect the dots looking backwards. Asset managers need to connect the dots looking forward with future conditions in mind. Awareness of future trends is key, and we must assert what these may mean to transportation. From heat waves to sea level rise, drought, dust storms, and so on." I quickly wanted to illustrate this need. I'll just go through this really fast. Take a look at the graph on the lower right. We know that greenhouse gas emissions are still trending upwards. And because of this, we're actually now on the worst case scenario trend towards a 4-degree rise, Celsius that is, by 2100. And scientists are warning us of extreme conditions. For example, with this 4-degree Celsius rise, that could mean that in the U.S., the monthly summer temperature could go up by more than 6 degrees Celsius, which is 12 degrees Fahrenheit. This would mean more extended and extreme heat waves. And the question is, what kind of implications would this have to transportation? Now, quick word about those two maps you see here, those global maps. The upper one shows a 1 degree Celsius rise in temperature, and the other one is 4 degrees Celsius. We're already locked into the 1 degree rise. And in the northeast, that would mean eventually an 8-foot sea level rise. The 2100 Commission folks allowed for up to 6-foot rise by 2100. Those are big numbers. That is if that rapid ice melt occurs. In terms of the 4-degree rise, that would be a catastrophic scenario, and according to scientists, the melting would occur within the next 2,000 years, so we wouldn't have to worry too much about that yet, but there actually is uncertainty as to how long this melting would take. Next slide, please. We're now going to take a quick look at what New York State is doing in regard to these risks. I wanted to mention Governor Cuomo's initiative, New York State Ready Respond. I think to transportation interests, the 2100 Commission is of great interest. You can look for that report online. And currently there is a great effort going on with communities about reconstruction. We have 102 communities participating in New York Rising. And they're developing their plans for the future. And these plans are due in 2014. Next slide, please. I wanted to talk about 3 vulnerability assessments that NISTAD is engaged in. And let's go to the next slide. The first one is the New York, New Jersey, Connecticut post-Sandy study with FHWA. We're working with 4 MPOs, with New Jersey DOT and Connecticut DOTs. I won't mention everyone in detail, it takes too much time, so I apologize. You can see the geographic area of extent right there on the map. The goal is to assess impacts, especially of Hurricane Sandy, within the area. And we will conduct an assessment of the damage that was done to the infrastructure. And currently we're working on identifying a set of representative assets for engineering analysis. We're doing the study so that it will be of benefit in other parts of the region. And I think all of you folks out there, you might want to keep your eyes on this one. Those representative assets, the engineering analysis, could be of use for you as well. Next slide, please. Another vulnerability assessment with FHWA is our pilot with the Nature Conservancy up in the Lake Champlain Basin area. And this particular pilot will include weighing ecosystem impacts. It will look at culverts and road segments, and it will develop an economic tool that will incorporate the benefits and costs of adaptation options. That's something that is very much needed. We need to know the costs and benefits of adaptation. Next slide, please. I'm trying to go fast here. The last example I want to mention is the statewide New York State DOT flooding vulnerability assessment, which is modeled on the 2011 Washington DOT pilot. We are looking particular at flooding, at our critical infrastructure, and we're creating a GIS data layer with these flooding vulnerabilities. We're reaching out to our maintenance and operations folks, hydraulic engineers and bridge maintenance engineers, to give us back where they know where their flood vulnerable locations are. This will all be combined into a GIS data layer and can be made available for transportation asset managers. In general, NYSTAD formally addresses system risks through a number of efforts, not just vulnerability assessments. There already are lots of processes in place to identify vulnerabilities. These processes and results will be incorporated into the TAM. Next slide, please. Here we go. We're getting to the meat of this, just 3 more slides, so I think I will make back up on time again. Let's look at what NYSTAD is doing with the transportation asset management. NYSTAD's implementation of AM is driven by the framework shown in this slide. This is not an organization chart. And at this point, transportation asset management has no formal organization here at NYSTAD, but a work plan is being developed under the FHWA pilot. The top level here that you see in orange, the Capital Program Delivery Committee, is actually led by Commissioner Joan McDonald, and she provides executive vision and leadership direction. The next level, the Comprehensive Program Team, is comprised of high-level managers from all business units. The very interesting team structure below in blue is made up of 4 teams in the area of bridge, pavement, safety, and sustainability. And these team structures also mirrored in the 11 regions that we have. Sustainability is it's kind of like a cross-cutting area, but it does drive investment decisions in the same way structure as pavement and pavement do. Climate change and extreme weather is being addressed through the sustainability teams. However, climate change and extreme weather is an issue that pertains to all teams. When the teams were independently asked to identify the greatest risks to the area, they all identified climate change and extreme weather as a risk that needs to be addressed. So it's one of our priorities. A word about which assets will be included in the initial TAM, that plan that's being developed. It will look at pavements, all the bridges, state and local, and the state-owned large culverts. That draft plan is expected to be completed by December 2013, so keep your eyes out for that. Next slide, please. If we're talking about climate change, extreme weather, really preservation is the foundation of resilience. If you have a good, strong, robust transportation system, the storms come and go, and hopefully the roads and bridges and the culverts look the same after as they did before the storm. We have a philosophy of asset management with 4 guiding principles that you see written on the slide. Preservation first. System, not project. We want connectivity, right? And we want to maximize our return on investment and make it sustainable. These critical links must remain functional, especially during states of emergencies, when transportation makes sure that vital goods and services can be brought to the people that need it. And look at what's happening out in the Philippines. The folks can't get food, water, medicine because transportation is not existent right now. It is just so very vital to what the needs are in emergencies. Next slide, please, which is basically my last slide. In conclusion, asset management planning offers opportunity to address resilience to climate change. Climate change is underway, and we're already locked into 1 degree Celsius rise in temperature on the global scale so far. We know this has implications. Climate change must be part of asset management. We need to define the risk. obtain data that transportation of professionals need. This is why in New York we are engaged in a lot of research. We all need to stay up with the science to be able to assess our vulnerabilities properly. And that is also why I kind of put up that slide about the global surface temperature and so on. Preservation is key, but not the only necessary element towards greater resilience. Under the NISTOD TAM business model, sustainability drives investment decisions in the same way structures, pavement, and safety do. As part of our risk-based asset management planning process, all 4 asset teams were engaged in assessing the vulnerabilities to the assets of their focus. And they all found climate change and extreme weather is a critical issue to address. Planners and asset managers need to be aware of this risk. As an example, the statewide flooding vulnerability map will help communicate weaknesses and alert to investment needs. NISTOD efforts underway in many areas are data, guidance, infrastructure assessments, collaborative studies, and NISTOD is setting the stage to address this risk through its asset management work. Lastly, last point, we need to keep up with the science. I think I said it twice already, and look at the infrastructure cycle to properly design infrastructure that will last through the storms of the 21st century and beyond. And last slide, please. I'd like to close with a quote by Aldo Leopold. He's an ecosystem thinker. He's a wilderness conservationist, or he was, rather. To keep every cog in wheel is the first precaution of intelligent tinkering. By that, I don't mean the transportation system, but we need to think of a much larger system. We're part of a great ecosystem here. With that said, I thank you for your time, and any questions to NISTOD Tamberg should be directed to Brad. Everything else I can handle. Thank you.
Thank you, Elizabeth. That was a great way for you to communicate why this issue has to be very prominent in all of our thinking. So that concludes our presentations for today. Thank you to all of our speakers. Big applause silently through the phone system. If you have any questions, please type it in to the Q&A feature on the webinar toolbar, and we'll take them in the order that you've put them in. So our first question is from Ahmad from Mississippi DOT, and he asks, with the shrinking resources that most state DOTs are facing, and since MAP 21 requires state DOTs to develop asset management plans that consider risk, will Federal Highway provide funding to develop such programs to meet the MAP 21 requirements? I think this is a question for you, Steve.
You know, with MAP 21, funding is available from the NHS program and the STPP, and as this for data collection, management systems. The state DOTs should work with the Federal Highway Division officers, to talk about the details of it. But we are in the works of developing a guidance memo that I would expect out in the next couple of weeks to our division officers, and for them to work with the state with regard to that.
Okay, our next question is from Shiv Gupta, and he says that Wisconsin is a cold climate state, and they have snowstorms and ice storms causing winter travel hazards. And are there any plans to consider the hazards due to extreme winter weather? So maybe if the speakers can chime in if you have plans that are factoring in extreme winter weather.
This is Elizabeth from New York State DOT. I think extreme winter weather is something that has been addressed all along. We do snow and ice planning. It's a priority that starts probably like in the summer months to plan for the winter ahead. We do need to look at changing freeze and thaw cycles and its impacts on pavements and any other materials. So there's definitely an area of concern there. And maybe someone else would like to add to this.
Yeah, this is Chad from Vermont. For VTrans, we too have snow and ice control plans that we implement, and probably a significant hazard for us might be like an ice storm, similar to what we had maybe in 1997 or 98, where we had quite a bit of damage from that. But on point is that winter hazards do exist, and they do need to be considered in the TAM.
And this is Mike. Included in the work that we did for SEPTA was looking at snowstorms as well, and the potential for increased incidence of those snowstorms.
Okay, our next question is from Jason Kennedy, and he asks, are states that are presenting today including betterment analyses when rebuilding? If so, what is their method, process that is being used?
This is Chad from Vermont. I'm not so familiar with the term betterment analysis or needs, but essentially we're looking at the vulnerability of our highway system, and we're seeing where we have risk. We're trying to do a better way to find those areas and to seek adaptations or alternatives to increase the robustness or resiliency of our transportation system. So in our presentation today, you saw us using LiDAR as a way to gather some survey information and to develop some relationships to some of those numbers and looking at certain characteristics of the river systems to help us arrive at an assessment.
I would love to add to this a little bit. If we look at our culverts and bridges, and let's say we do know intense precipitation is increasing, logically we could open up our hydraulic openings more. But there is something called cost and tight budgets. So in order for a DOT to say, all right, we're gonna increase our openings, hydraulic openings by 30% across the board, is a very, very costly approach. So there is something called cost benefit, and it would basically, with tight budgets, have to be looked at on a case-by-case basis. We are developing an economic cost benefit tool with the Lake Champlain Basin study, where we're doing the work with the Nature Conservancy, and we're really looking forward to this tool to be able to better weigh cost and benefit of adaptation options in design.
To piggyback on Elizabeth's comment, this is Chad from Vermont again. We have looked at increasing our hydraulic opening sizes, and we're working with the fluvial geomorphologists more now than ever before to definitely assess each bridge, each culvert on a case-by-case basis, and just kind of integrating their input earlier on in our process.
Okay, and our final question, which I think Elizabeth already answered partially, was, is anyone doing return on investment analyses as they're developing their adaptation plan?
This is Vermont. We are heading down the road to getting our TAMP working group together and looking at our TAMP, but return on investment is certainly one of those items that we'll be looking at real closely. Presently, we're not doing that right now.
Now, I could also add, when we rebuild after a disaster, after Irene, after Lee, or Sandy, FEMA sometimes really needs to see, if you want to build this better, show us how. We need to see all the engineering calculations on this. And there is a little bit of an effort underway that we need to get these processes improved so that we're not putting back what was there before and are just as vulnerable in our investments for the next storm. So there are a little bit of efforts underway to make those efforts a little bit smoother between the DOTs and FEMA. On the other hand, if we're doing work under mitigation hazard, if communities or states or municipalities actually have adopted standards that need to be put in place, then FEMA, from this aspect, just to discuss FEMA for a second, will say, okay, we will approve your higher standard, and we will pay for this improvement, so to say, and you will be less vulnerable for the next storm. I hope I made this clear enough.
And this is Mike. I would just like to point out a couple of things about the return on investment analysis. If we're looking at past events, the return on investment analysis is not really all that bad. But we know that under climate change, the past is no longer a good indicator of the future, so we have to incorporate in our calculations the probability that such future events will occur and the frequency with which they will occur, which kind of puts the analysis in a different vein. We are very engaged in trying to develop some of those methods for evaluating adaptation options. But to my knowledge, no one has really done it particularly well going forward because the numbers are so difficult to come up with in a strict sense. Many agencies that I'm aware of have been able to score the analysis, which gives you some information, but it is difficult to come up with the probabilities and therefore the actual return. Oh, and one final thought on that. There's two ways of looking at this. Certainly it's the return on investment to the agency operations. What is the investment the agency is going to make, and therefore what is the return on that investment? But I think that you really have to look at this from a twofold perspective, as I kind of indicated in my presentation. One is certainly the return on the agency's investment. The other is the return to society. And what is it worth to your service area to make that investment? So, thanks.
Yeah, this is Steve from Federal Highway. No, I don't think we've been asked that question too often, but if you're looking at the purpose of an asset management plan, you're looking at the inventory, you're looking at risk, you have a life cycle cost analysis that's programmatic, and then you're looking at a financial plan, your resources, what you have, and how the whole system's going to perform in the condition. I think, the economic analysis you're talking about in some cases is a key. Do you do it or not? As you do your investments and, trade-offs, investment scenarios. How complex it'll vary on the risk and so forth. But I think it's a key to make some decisions as you move ahead.
Thanks, Steve. One question that just got raised that I think is directed at you, Steve. It's from Johnny Weisbeck. If resiliency assessment and risk assessment determine that a structure such as a bridge should be structurally improved in order to assure a minimum level of service for that route in an extreme weather event, is FEMA mitigation funding available to support that improvement?
I apologize, but I do not have an answer for that question. If anyone else on the line does, so please jump in. I don't get involved with the FEMA type funding.
I apologize. I couldn't listen to the question because I actually needed to get offline to go join a conference call. So I really apologize. But I think you should write the question down, and some of us will be able to get back to you.
Yes,
okay.
Please.
That's what we'll do. We'll raise it to the group and see if a response can be made for you. All right. So just in closing, our next webinar is on January 22nd. It's on data needs, issues, and governance for improved management of highway assets. Please suggest ideas for future webinars. We have the next set that will start after the January one, starting March, and we are seeking subjects for those. And then again, you will be able to find today's presentation deck along with the audio recording of the presentation in the ASHA website under TAM. www.transportation.org and click on webinars, and you can also go to the Federal Highway Asset Management website, and there'll be a link to the material as well. Thank you, everyone, and look forward to seeing you next time in January. Bye-bye.
Thank you, everybody. Bye.